make a pretty good mobile web browser using webkit. We have Android, we have iPhone, we have the browser, the BlackBerry Torch, and we just see more and more. There's also less bootstrapping because a lot of the pieces needed to make a good mobile browser is already in place. So, we're targeting a totally different form factor than a desktop browser. On a mobile device, the screen is usually quite small, which makes for a lot of different problems. And we're not using a keyboard and we're not using a mouse to navigate. So we have a totally different input. You might say to yourself, well, Nokia hasn't been really good at doing web browsers. The track record isn't really that good. Well, you can say that today, that might be true, but actually, Nokia was the first company that brought a WebKit to a mobile browser, to a mobile platform. And they did that many years ago. And they did pretty well. But there's a lot of things that has changed since then. For instance, today, there's Wi-Fi everywhere. There's access to 3G. The cost plans are a lot cheaper than they used to be. Before, people weren't really using an internet browser on their mobile phone because it was really slow, it was really expensive, and it couldn't really render the real web pages, so you had to get these WAP pages with like limited content. And it wasn't really what people wanted. So a lot of these things has changed. Today we have nice data plans, we have larger mobile screens, we have a different way of interacting with the content using touch, using your fingers, and we have more powerful devices. So this means that today it's possible to actually bring the real internet to mobile devices. You have more screen real estate and you have more powerful processors. So you can actually load these real pages and process them and show the content to the user. But there's a lot of challenges in making a mobile web browser. First of all, as I mentioned, we have the small form factor. Things just doesn't fit on the screen. You can't really see a whole page. Then you might have to make it smaller, and then the text is so small that you can't really read it. So there's a lot of different issues. Another problem is that loading the page from the net, where we're having a slower net connection. We also have to understand parse this on a slower processor. Then we have to go through the layout page to figure out where should the text be. Should it be reflown? Should it be a box here? We have to do all this before we can paint. And then we have to paint. So that's very slow in comparison with a desktop browser, where we have maybe a 4-core computer. Then there's something also very, very important. Touch interaction requires a very, very responsive user experience. I'll get into that a bit later. Also, our fingers are pretty huge. So you're trying to click a small link with a big finger, and you can't even see where you're clicking. So, because content is small, you normally zoom out, so you can't see it. So we'll talk about that as well. There's also the web apps. People are trying to make web apps today, like email, clients, etc. So that brings a whole lot of different challenges. And we'll talk about that at the end of this presentation. So let's look at the small form factor. There are already some really, really great ideas on how to deal with it. The first is zooming. It needs to be possible to zoom out or zoom in to look at what is interesting for you. Some good ideas, for instance, you can do like double tap to some specific area of the page. For instance, you have different columns on a news page, like New York Times. Double tap on one area, and you will zoom in. I think I have an example of that here. At New York Times, I'll double click on an article, and automatically zooms in so you can read it. This is not perfect, and there are areas where the page where you can't find these nice areas to zoom into. So we also wanted to be able to do that manually, so people can like do pin zoom with 2 fingers. I want to see this area. Maybe you can move the page around with the same time. Pin zoom. I don't know if you can see these 2 dots, like the 2 fingers. I'll try to print out, so I can see the whole page. So we'll just go back and pins in, so you can look at more contents. But there's still a lot of issues, even though you saw that I zoomed in here. It might be that the text, or that column is pretty wide, so the text becomes so small that it's impossible to actually read. There are different solutions for fixing this. Android comes with something called text reflowing. I have an image of this, the same article. I don't know, it's pretty dark. So it means that when you zoom into something, you don't want it, you want the whole text here. And now, in order to be able to see it, you have to zoom into this area. So you have to read here, scroll to the side, read the next, scroll back, start the next line. And that's pretty annoying. So Android, they fixed that by reflowing the text. So it means that when you in a specific zoom level, you just relay out the text. So everything fits into one view. This is something that's really, really hard to get right. I don't know if you have tried Android, sometimes it just doesn't work. And you end up with text that's always outside the view. You try to move it a bit, it's still outside the view, because it doesn't reflowing again. Something else is that I said before, even layouting is really expensive. So it can interrupt the whole user experience. And there's a third issue, is that when you zoom in, you get this nice animation, everything zooms in, and then everything just changes position. So maybe even what you wanted to see is now outside the screen. So the iPhone has a different solution for the same problem. It's known from desktop browsers that you can have a setting like minimum font size. You say, enforce this minimum font size. Never show font smaller than this. The iPhone brought that a bit further. They said the minimum font size is per width. So when you can double tap some area, they enforce the minimum font size when you zoom into the area. So if I zoom into this area again, they'll say, well, the font size of this area has to be 10 or 20 or 12. This means that the original page, you'll actually see that maybe the font size in the first column is like this one, and then in the middle column, because they have a better wider width when zoomed in, the font size might even be bigger. I bet none of you have noticed that on the iPhone. You don't really see it. If you know it's there, you can go to New York Times, this page, and you'll see that sometimes in some columns, the wider the columns are, they often have increased the font size a little bit. It doesn't annoy people. It just makes sure that you always get a nice animation, and it's always possible to read the text when it's zoomed in. But there's a lot of different ideas, and there's probably new ideas that can be explored as well to solve these issues. So, let's get back to the fingers. As I said before, our fingers are pretty big. So it's really, really difficult. On a computer, you're having a mouse that has one dot. You click on one specific point. On a finger, it has like a surface you're clicking on. And many times people are even shaking. It's really, really common. Like, everyone shakes a little bit when you try to click on something. There's a little friction there. So you move the page a bit. So we need solutions for dealing with these things. Like I said before, like one of these pages, that one of the problems we have in this conference is that you're looking at some little area and you want to go to the next area. You need to be able to pan around the page pretty fast. On a desktop browser, you normally have a big screen so you see everything, and first a little later you start scrolling a bit. But on a mobile page, you often zoom in to some specific area, and you want to be able to get an overview and get back soon. So the double tap is pretty good for zooming into a specific area. And you can do the same way that if you double tap the same area, that it will zoom out so you get the overview. Still, it doesn't solve everything, and there are pages that don't even have like zoomable areas. Maybe just text. So we wanted to be able also to pan around fast. So we make it possible to you can pan around with your finger, like you're on Android or the iPhone, but still also if you pan on a bigger area, with a little force, it will start doing some kinetic scrolling, making it scroll faster, so you can easily get to the content you want to see. Also, as the screen state is pretty small, you don't want to have scroll bars. It's not nice clicking to scroll, you want to pan, it feels more natural, and it also takes up space on your screen. So most mobile browsers, they don't show scroll bars. Instead, they use what they call scroll indicators. Things that show themselves when you're panning or pinching, and then disappear when you don't need them. Because when you're panning, for instance, anyway, you're panning pretty quickly and you're not reading anything. So it's pretty good. You can just look at the side, see the scroll bar, you can see if you're at the top or at the bottom. You can also make other ways to show that you reach the boundary, like the bottom of the beginning, just by doing a bound screen or make your cell phone shake a little bit. There are different ways of doing that. As I said before, fingers often shake a little bit, also when you click. So it's always a good idea to have some thresholds. Like when you click before starting panning and say, okay, you have to move like 10 pixels before you start pinching, you have to move 10 pixels, just to ignore all these small imprecise movements that people make. So this is very common, and you'll notice that if you take an iPhone or an Android, this is implemented this way. If you start pinching, you can pinch like maybe 5-10 pixels before it starts pinching. And the same thing with moving. Which means that if you click on a button, it doesn't start moving the page, or you can actually scroll, which would be really annoying. Another way is that if I'm trying to pan, I'm zoomed into a page. Like this one, I start to pan. It's very, very difficult to do like a movement straight up. You always move it a little bit to the right or to the left. So you can try to guess or look at the various. You find, okay, the guy probably wanted to pan up upwards, and then you just ignore it, unlock it in that direction. So you don't, if you're reading an article, you won't suddenly scroll out of it and have trouble scrolling back again. So there are all these different small tricks we have to apply to use touch as input. Something else is, that I said before, is that our fingers, when you click on the device, you have a touch area. So you'll need to find out like a point where you clicked. Normally, this will be the touch area you get from the touch point, and normally you can do that by user test. You find out that people actually want to click a bit above that area, like where I put the dot here. So you can take that as a starting point. But instead of just looking at what's below it, because most of the time you make them miss it, because your big fingers, they're unprecise and you can't see where you click. So we use an algorithm in WebKit that will try to figure out whether anything clickable in this area where I clicked. So was there a link just below it? So the user probably wants to click on that link, and then we will click on that for the user. Another big issue with having scrolling or content and using the fingers and scrolling is that we want it to be like one area that you're scrolling. It really confuses people. If you're scrolling, suddenly you hit some area, sub-area that's scrollable. That will really confuse people because suddenly you start scrolling differently. That could be like a page that has frame sets, or a page that has like iframes that are scrollable. So, for instance, what the iPhone does is it says there are no scrollable iframes. So they simply expand the iframes to their size, to the size of their contents. You would think that was something that would break a lot of pages, but in practice it doesn't. They do the same thing for frame sets, we will also do. For instance, this is a test, the WebKit test. It shows the frame set, it's a bit strange. But you see, like, if you had this on a small phone, that would be really difficult to read the text. You have to pan a little small area, you have to pan this area. You just want everything to be like one big area that you can pan. So the idea is that we expand all the sub-frames to their contents area. And then sometimes you get some area that not occupies, and you expand these other frames a bit further. So you get something like this. So this is with frame set, frame flattening enabled. So you get one big area that's scrollable. So the conclusion is that touch is a really, really nice way to interact with web content. It feels very natural, it feels easy. But there is one huge issue. If you really feel it if the page is blocked. Like I said before, if you have a desktop browser, you open up, you have a big desktop browser, you load a page, there's the contents, you almost see everything you want to see, and then you start scrolling. So normally you start scrolling when it's already finished loading. Or even if it blocks a bit, you don't really notice it. But on a mobile device that's slower, where you're using your fingers, you really feel when things fall. and browsers, they store alloys. They do that during loading. The most common idea is to separate the UI and the web in either different threads or different processes. One way to do it is that you have like the web, let's just talk about the UI process and the web process. So you have like the web process, it will paint something, it might store the painting sequence, send it to the UI process, you can then repaint it. This is, from what I know, is what they're doing on Android. Or you can like share the painting area, like it paints into some shared memory of the web process. When you're ready, you can show it on the UI process. What is really important is that everything is non-blocking. So we need to design a whole new API that makes sure that we can do almost everything non-blocking. Because if something blocks, everything blocks, and you feel it. There's one example I've written down here. Think about it, a page has like fixed elements. So if you have a fixed element, it has to always be at the bottom. As is the web engine that's painting it. Every time you scroll, you have to tell the web engine, I scrolled, and you have to tell it back for each pixel. Okay, this it will have to paint and re-update. But if we did it this way, it would be blocking the whole time. So we have to find solutions for all these small corner cases, and I tell you, there are a lot of them. Sometimes it's not the perfect solution, it breaks contents, like the iPhone doesn't support fixed elements, for instance. I believe there are very few mobile browsers that support that. I have some good ideas how we can support at least 90% of fixed elements, but there are all these different issues which we have to solve. And it's really important we do this while people are panning, pinching, or while we do rotating. Our solution, this is a solution similar to what they're doing on the BlackBerry and what they're doing on the iPhone, is using a synchronous tiling. It means that we look at the whole concept as one big image. Like we paint the whole concept into an image. Then you can pan an image, you can scale, like pinch, zoom an image, and you can rotate it at 60 frames per second. It's like the magical number. So, here's an example. The green part, that is our screen, is what we're currently looking at. And the gray and the blue area is like the content. So the content is divided into different tiles. Some of these tiles I have called edge tile because I've changed the size a bit, because I want to be able to still maybe pan out and maybe pan back. You know, want it all to be shown. But this is the basic idea. So, when a tile becomes visible when you're scrolling, if it's already painted by the web process, which we're doing with, for instance, shared memory or memory net IO, well, then we can just split it. Just paint that tile on the screen. If it's not available, we can do some indication that the content is not ready yet. For instance, by painting checkerboards, which is something that's known for most of the imaging applications like Photoshop or even the iPhone is using. Like it shows that the content is not ready yet, we need a shortly. This means that we have decoupled the whole web engine from the UI. The UI just paints tiles, images, that sometimes get updated by the web process. Of course, pages, they change, they're animation, they're counters. So when a page changes, like on one of the tiles is visible, we of course have to update it. We don't have to repaint the whole tile, or we just paint like the area. We have to make sure that we paint the area for all tiles visible, so that all tiles stay in sync. We can't have, like, for instance, a tile that's outside the view that wasn't updated, and one that's inside the view that got updated, because then you might see that when the tiles they interact. Like here it's painted and here it's not painted. Like if you have to have a blue box, then you see the blue box here, but the blue box doesn't appear here. So all the tiles have to always be in sync. When you get updates regions to tiles outside the screen, a common idea is to store it like a dirty region. You don't need to paint it right now. You just mark this area of the tile is dirty. If you get another dirty area for the same tile, you might just merge those two areas. Or if it's too big, you might just discard the whole tile and repaint the whole tile next time. So this is not exactly enough to make sure that on the device like it's 60 frames per second for padding, painting, and rotation. Because we're having the repaints, we're having loading, can happen load while padding, and there can be JavaScript executing. So the basic idea is that you just suspend all JavaScript, you're padding, you're pinching, you're rotating, people don't care if the file is updated. You suspend JavaScript, you defer loads. If there's some load going on, do it later, when people have finished padding, and ignore repaints. Because people don't care about these things, you don't notice it, but it just makes sure that we can really paint things in 60 frames per second. This wouldn't be possible, for instance, if you did a pinch zoom on a page. I don't know how long it would take to repaint that area, because there might be more text, there might be more rectangles, and it might take a bit longer. So when we do pinch zoom, we do something more. We don't paint anything. So basically we store the whole tiles. We keep the tiles what we had, and we just scale it, just like an image. You have to figure this whole tile as one big image. You just scale it up, we can do that 60 frames per second without problem. When you're finished, we repaint everything. So it looks nice, sharp text. It's readable. Rotation is also a bit tricky. Normally you want to see the same thing. If I'm looking like a portrait, I'm reading nationalist comes in for the flavoring, so I'm rotating, it should just scale up so I'm looking at the same area. So that's the basic thing. Look at the difference between the width and the height, and either multiply or divide that factor depending on how you're rotating it. The iPhone did a bit more. They can make it possible for web developers, web authors, to decide how content should be laid out. This is something that's particularly very important for web applications. For instance, if you look at the Google page, they're meant as web apps. It says like the maximum scale is 1. Don't do this scale up when I'm rotating. I don't want it. So it would be if we look at normal Google here, rotated, there's some area missing. So what we do, what all the others do, what Android, what iPhone, what everyone are doing, because everyone implemented this today, even Opera and Firefox and mobile, is that we have to relay out with the new view. We just said, okay, it doesn't fit. We relay out the whole content as it has a width that was larger. Basically, like what you see there. But we don't want to do these relay outs while we're rotating, because then we can't ensure the 60 frames per second. So we have the above as a middle step. We rotate it, we keep the content that it's at, just paint some checkerboards or something else similar, where there's no contents, and when you finish, you relay out. So you get a smooth animation, rotation animation, and then you get the contents that you want. So, summing up, you freeze the backing store, you suspend the JavaScript, paint, etc. You keep your own contents, rotate, and then you relay out and unfreeze. So, let's go on to web apps. I'm not going into details why people should make web apps, when it makes sense, when it doesn't make sense. I haven't made another presentation about that. There's a link here for those people who are interested. I think our slides will probably get on the FOSDEM page later, so you'll be able to check that out. But let's just say that web apps make sense in a lot of situations. So, how do we go about supporting this? Well, the idea with web apps is that they should be behaved like real apps. What does that mean? Well, it means that one CSS pixel should be like a device pixel. You don't want it to be scaled. Normal apps don't have a scale. You don't want to have pin zoom, at least not the whole application, because normal applications don't have that. And you want to be able to control like touch input yourself. So for instance, you could implement in your web app like pin zoom, etc. So mobile browsers used to today support touch events, which makes it possible for the pages to deal with the events in the way they see fit. But that also means that every event you get, touch event you get, you have to send to the web process, which will then have to handle it or ignore it. If it ignored it, it has to get back to us, and then we can do our pinging or handling. But it means that we get this dependency then, or slowdown, send to the web process, wait for it to return, which is what we don't want. So there's some tricks that can be applied. Like you can check if the page actually registered a listener to the touch event. If it didn't, don't send any events to the web process, just deal with it on the UI side. For controlling the layout, there has been a lot of different ideas for doing that, a few different meta tags. But the latest one was introduced by the iPhone. It's called the viewport meta tag, and it's been quite popular. It's used on most of the mobile pages out there. Basically, the iPhone will lay out every content as your web browser had the width of 980 pixels. On Android, the device manufacturer can decide when they want it to be 980, 1100, or some values like that. They have a few values to choose between. But for instance, if you even open up the Apple site with 980, it won't fit, because they have this big image at the top that is larger. So they will need that page to be laid out with a larger view. So they added this meta tag to give this control to the web order to decide how to lay out content, how to deal with scaling, etc. So the features is that you can define the layout width. You can even define the height. It's not very used, but it's possible. Then you can define the initial, the minimum, and the maximum scale. So you can control how you can zoom in and zoom out. And it's even possible to just disable or enable user scaling. So here's a few examples. This is one example that shows how it could be done. I have to say that this is defined in portrait mode. For instance, the original iPhone had like 320 pixels and a DPI of 160. So this will be to make a page look pixel perfect on an iPhone. So we set the width to 320 and maybe maximum scale of 1. So you can't scale in, do anything else. Today, as people have different devices with different resolutions, etc., it's possible to define like device width. So if your device is 480, it will lay out as with 480 as today. One of the big issues with web pages and web apps is that, for instance, if you have a button, a scroll or whatever you have done, how it's shown to the user, the size you will have, like how it is big in comparison with your fingers, that depends on the DPI of the device. If I have a high DPI, it might be so small that I can't really interact with it, and that's not what we want for a mobile app, for a web app. So I set the iPhone has a DPI of 160. So when this problem starts to arise, especially with Android phones, coming out with DPI of 240, people start to figure out how should we resolve this issue. So Google, they made a definition of something called density independent pixel, and that's defined as a pixel on a 160 DPI phone. That is because most, if not all, web apps today are designed with the iPhone in mind. And now that the Android and the other application does exactly the same. This is how it's going to work. So, if you look at, for instance, Firefox in Nokia N900 on other Android devices, DPI 240 or beyond, they actually scale up the content. So if you had a 320 on the page, you actually scale it up by 1.5, like 240 divided by 160. This is not what you always want, because, oh, I bought this really nice device, and it's beautiful screen, nice DPI, why is everything scaled up? So Android added something called a target density DPI, where it's possible to override. By default, it's set to, I think it's called medium DPI, which is 160, so it's possible to set, for instance, to device DPI. And then via CSS, figure out if it's scaled or not, so you can load a different CSS file with better resolution, with images, bottom images with better resolution. So, summing up, making a mobile browser with touch devices has a lot of different requirements than making a desktop browser. Our focus is on the touch interaction, on seeing your content and interacting with it. So we need touch surveillance, we need this engine application separation, and a lot of small tricks to make everything work perfectly. I've just shown a few of them today, but there's a lot more, a lot of ideas you can do to make it really work. And for doing web apps, the application needs to support a web orbit to decide whether the browser should support scaling, maybe whether it should even show the Chrome, etc. So I hope you have enjoyed the show, and I hope that you have some good questions. Okay.
The presentation then was mobile, right?
Yes.
So I guess the webkit platform is running on AWS.
No. The Qt webkit?
Yes.
No, the Qt webkit is based on top of normal Qt.
Yes, but you can run AWS in a platform that doesn't have an X11 VM.
Yeah, I guess you can do that. It's just like I said, it's based on top of normal Qt. So whatever Qt can run on it, it can run on. So you could use QWS. You can even, if you want it on a Windows mobile, but it doesn't support X, you can use the Windows thing because Qt supports that. Well, having the 60 frames per second is something that, okay, well, he was trying to ask about if it's usually like the QWS on an embedded platform with Qt, how you can ensure having that 60 frames per second. It's not something that we in Qt can ensure that you have 60 frames per second on a device. It's something the device has to provide. If the device can support like 60 frames per second for panning, pin zooming, and rotating an image, well, then with this idea you have detailed today, it's possible. That because the painting is done separately from showing it, it's done in the web process. For instance, for most mobile devices, you could make these tiles like maybe the OpenGL textures. So the shared text that you write to them, the scale and everything is done in the graphics card. You would need to provide a platform that can give you 6 frames per second for doing pinching, panning, and rotating an image. And there's something you have to be careful about, that is the texture upload. We're using OpenGL. These are different tiles. It's not just one image, it's a tiled image. It's made out of tiles. So every time you have to blend something, you have to maybe upload that texture to the video memory. If that is too slow, you might stop a little bit while panning.
You mean like a quick song?
Yes, for instance.
What the actual dependency and you produce a quick song? What is the ratio? This is kind of synthetically, right?
Not really. The way this can be done is, like I said, you use a shared memory area, so you can implement it the way you want. This is just basically the ideas how to do it. Implementation can vary depending on your hardware. etc. Yes?
You mentioned people said you wanted to draw tiles separate so that you can get basic model. Is it possible to predict the simulations and then keep those tiles that are often necessary, or is that too much on the block?
Well,
You said it's not based on something.
well, you can do something before. If you're planning to know them, so you don't have to. But actually having a tile is always a bit what you're saying, because I'm painting a large area. So if I already have a tile outside the area, I might make the definition that always paint 2 tiles outside the visible area, and then just paint them when they're ready. So you just schedule a layout, say, paint these tiles when they're ready. But don't paint any more tiles than these, because they're memory constrained as well. So it's all like a trade-off, something that is performance. You have to find out what makes more sense, what gives the best user experience. Of course, the idea is that you shouldn't use all the memory of the device, and you should try to make it possible to make it almost impossible to see the checkerboard areas, so that you don't run into it the whole time. But this is like, there's a lot of things that you can do now. Yes?
You use only the API scale for the components or for scaling
Well, the DPI I was talking, he's asking whether you are only using the DPI for the font scale or for everything. Well, with the DPI and the viewport meter effect, we're using it for everything.
also images.
Yes, it's basically, as I said, we're painting the contour with the scale. So we just take the DPI into account. Any other questions? Okay.
You said something about the connection of the application. You probably have lots of
Well, he's asking how responsive should the application be for the user to notice it. Well, that is basically what the 60 frames per second is about. That is what your eye can register. So if you can do better than 60 frames, or like at least 60 frames per second, then that's what you should aim for. You don't really need to have something like 50 frames per second, like more than 60 frames per second. You don't really need that. But less the user can perceive. More questions? No? Okay, then thank you very much for coming.